Hey everybody, Facebook friends, YouTube subscribers, guitar enthusiasts, people who want to learn more about fitting building block patterns into modal cage shapes. That sounds like no one. But you know something? If you want to be unique in this world, do something that people haven't done before. Nobody thought to do it. They didn't want to take the trouble or just didn't think of it. A lot of the things in guitar become easier when we chart them out. So I've got this chart number 113. By the way, I have a bad cold, so we're just going to go through with the lesson because just like Zoom and all that internet conferencing, you can't catch a cold through an internet connection, at least not yet. So this chart has a few attributes before we start zooming in. And if things start to look like an integrated circuit up here, that's good because this is a high resolution chart. The true size of this chart, and I don't think they make printers that big. It's not tremendously big, but let's look at the size of it in, let's say, inches. It's 135 by 62 inches. Now that I know because putting the frets on this, the note frets on this guitar, these guitars of mine, I had to use that image program to do it in centimeters. And these frets are measured and then made down to a half of a centimeter. So that's pretty small. That's about a half of a centimeter is a little less than the shaft of a pin size. So we want to be accurate, but then when I cut it, and fit it and all that, it's all, in an exact science because these frets are actually trapezoidal shaped. Everyone knows what a trapezoid remembers being taught trapezoidal. It's just slightly trapezoidal. Okay. So I got a bad sore throat, but we're going to go through with this today. So one thing to remember about making inlay frets exactly, if you are, or cutting them out when someone's made them for you already, is to fit the trapezoid inside the square. And I'll show you what that is. So let's just say we want to like a little drawing area here real quick. So here we'll make a little blackboard right here. Okay, so we have a square fret. It's going to look like that. Let's say that's pretty far down on the fretboard there, isn't it? That could be like your F fret, in E-tuned guitar. So we want to fit a trapezoid to that. It's going to look something like this. Like this. Now the color is kind of light, but that's what it's going to fit to. So we would do that instead of, we would fit it to that instead of cutting it like this, which would become bigger than the square. You would want to keep it smaller than the square. So you would want to fit it within the measurements of the fret. So what we have is an outer we have a lower and an upper height on the fret. The upper height is going to be taller. Okay, but we use that as the tall part of the, so the part of the fret that's on the left side is going to be a little lower. Okay, so let's look at that F fret again. Now this F fret isn't really real shaped. What it means is the lower frets where the F is and the E here are supposed to be longer and then getting shorter until you get up to the other frets, you know, and then they get smaller and smaller and smaller to make a smaller wave, sine wave, if you will, you know, as the string vibrates, boom, 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 you know. And but that would be the measurement. And sometimes I'll just put the same measure, but I do keep different measurements for the left and the right side of the fret. Okay, and at times I'll have to keep them the same when we get up to the smaller frets. The measurement, it's so small of a difference. But down below, sometimes, you know, I have to make a judgment call on what is going to be the fret size, you know, so that's it. So I'll usually, what we'll do is I'll usually call it go with the taller part, and then the left side of the fret will be slightly shorter. This is to prevent any overhang of the frets onto your sliding area here. You don't want that getting in the way and starting to feather out. It reminds me of the origin of feathers that I researched once. The reptiles had scales, and those scales started to feather out. That's how they formed feathers. That's what they said in that particular Google search I had. Okay, so I'm doing this lesson today. My wife is at church, and I wasn't allowed to go because I'm sick, but I'm doing a lesson. So let's get to it. Now, I had made a lesson yesterday that was supposed to be discussing what we were discussing today. And I only got to it in the last segment. And I even made a mistake that was a pretty obvious one. And so I took that segment out. So it went from an 80-minute to a 70-minute. And I'm still waiting for Facebook to upload the whole thing so I can look at it and see what that edit looks like going from segment 1 to segment 3. But last time I removed a 10-minute segment, it was fairly seamless. So let's get down to it. What do we got here? This looks pretty complicated, but don't let it fool you. The one pattern, okay, let's start with our little patterns here. These two here, the stack of 3 long and the stack of 2 long, both include the 4 and the 7, although stack of 2 long, or S2L, earned its name before the 4 and the 7 were added. It's just a building block. So if that 3 was an E, the third of C, in the key of C, all the numbers are done in the parent key. Usually C for my discussions, but it could be any parent key. It could be B, it could be C sharp, it could be C. But the numbers are staying in the parent key. So, okay.